correct. Position vector, you must remember, position vector is always with reference to the origin. Okay, it's always with reference to the origin. Alright? It's unlike free vectors. Free vectors lie freely in space. Okay, two lines, we can have the same direction vector. Alright? But we may not have the same position vector. Alright? If they still have the same position vector, it just means that they intersect. Alright? So from here, if I give you this line, how do I describe this line? It's just like your coordinate geometry. We need a start point. We need somewhere to start with. How do I know? How do I find this line in space? We have to point. We have to point. We have to point towards one of the points on the line. Okay, here. This is one of the points on the line. How to indicate this point? Okay, so I put it down. Reference to the origin. Let's say I call this A. Okay, this is a position vector. One of the points that lie on the line. I can go to the left, I can go to the right. But I need to know which way to go. I need to know which direction to go. Okay, so this is we need to indicate a direction. So direction, we need a direction vector. Alright, with the direction vector, we are able to label all points on the line. 1 time of M, I have this. If I have 2 times of M, this is A plus maybe 1 time of M. If I go forward some more, maybe this is A plus 2 times of M. If I go forward some more, sorry, a bit curvy, A plus 3 times of M. It can go on and on. 4. It can go this way. A minus 1 time of M. But you can see that all these numbers, my negative 1, 1, 2, 3, they just go along the line, right? They just describe any point on the line, right? So what does that give you? That gives you a vector equation of a line. And M will guide the direction. Okay, will guide the direction. Alright, so that's the in general, the vector equation of a line, we write it as A plus lambda M. Okay, where your A, if you write it in this way, R, A will be your position vector on the line. Alright, and A is a direction vector. Okay, so you must know the difference. Okay, this one important. So this one need to know this lah. Sorry? No, where's your wallet? Where's your wallet?
I don't know. I think I left it.
Okay. Wow, this one, start only, come late. Why so late today? Who's the teacher? No teacher? Run on. I also run here.
A with this degree is position. A is a vector. What is position? What do I position?
Here, right? In position, we can write this way. So now ask, how do we describe a position? How do we describe a free vector? Okay, let's say if I do this right. I give you a parallelogram. Maybe O, A, B, C. Put the paper off, right? Okay, O, A, B, C, right? So OA, this is the origin, right? Okay, what is OA? What kind of vector? Position, right? So it's a position vector, right? Okay, so it's a position vector. If I represent OA using a free vector, A, can? Okay, so what kind of vector is A? This A squiggly. This is a direction vector, or we can call it a free vector. Alright? Why? Because very simple. You can see that I can put A somewhere else. If I shift it to the right, alright, I can also say that this is also equals to A. Can you see? They are equal, parallel, facing the same direction. Two vectors are equal if and only if they have the same magnitude and pointing in the same direction. By default parallelogram, they should be the same direction. Okay with this? Okay with this, it's recorded. Don't go back, watch 1,000 times. Okay? So from here, number 1, we need to find the vector equation of a line. Okay, of the line passing through -1, 3, 2, parallel to the vector 4, negative 1, 2. Okay, so if you watch my video also, it will help lah. Okay, so but if not it's okay. So number 1, with negative 1, 3, 2, we have a line passing through negative 1, 3 and 2. Parallel to the vector, some vector over here. This vector is 4, negative 1 and 2. Right, two lines are parallel means they have the same direction. So I can also say that this vector can also rely on this line. Okay, it's also 4, negative 1, 2. Very quickly, we can write out the vector equation. Vector equation means your answer is a vector. Cartesian equation, Cartesian means, last time you studied Cartesian means x and y. So Cartesian equation means x, y, z, x, y, z. So Cartesian vector equation is just a position vector, negative 1, 3, 2, plus lambda, a scalar of 4, negative 1, 2. It's a BMQ 1A. Okay, so what I need to do is from here, lambda is any real number. Okay, lambda is any real number. Okay, from here, what you can do is to write R. Okay. Yes. Okay, can. This is 1A, Okay, can. Can. 1B, okay. Anybody cannot do 1B? Or can don't pass it hot. Even now, we're smaller, we're even smaller, we're more comfortable. Okay, so you can go pace. So don't worry, I put a lot of safety net for you. If I'm not around, one day I'm no longer around, the videos are still there online. Okay. Okay. Pass through the origin. Okay, so 1B, very quickly, what's the answer? Lambda 2, 1, negative 5. Okay, okay, this is your 1B. Okay, quickly 1. Thank you. What next? Given that they are parallel, maybe I ask Ricardo, what's the next thing I will do? Very good. Why do I separate the R? Why do I separate the R? You want to find the vector equation. Why do you want to find the vector equation? Very good, Ricardo. Okay, so Ricardo wants to find the direction vector here. Okay? Because he knows that if he finds the direction of the first line, that also gives him the direction of the second line. Because they are parallel. So quickly, what do? We separate the constants the numbers from the scalars. Okay, so here 2, I go to the left. Negative t, then I put negative 1. Negative t, right? Negative 1. Negative 1, negative 1 plus 0t. Okay, t itself is just 0 plus 1t. I separate the scalar and the constant. Okay? And plus. 你要去 Geo 找一下，去 Geo 找一下。what is that?
He never called it.
What dumbass. Okay. Then after that, you have your direction vector t negative 1, 0, 1. This just means that here, your direction vector can also be negative 1, 0, 1. Okay, vector equation online is you bet lah. I mean, you can bet. Confirm come out one. Sure no, sure ask one. Okay, so you must know. Vector will definitely come out in heavy quantities for your. And you have a lecture test coming up. So must take it seriously. Okay. Okay. Then after that, 1C. So with that, right? Very quickly, you have one position vector. Check. You have another direction vector. Check. Okay. So this is your position vector. This is your direction vector. And with that, we are ready to write out our equation. So for BMQ1C, alright, our vector equation will be 314 added with lambda negative 1, 0, 1. Okay? Okay, what does R represent? If you break out R, what is R actually is? What is actually R? R is just your XYZ. Actually, R is just XYZ. Okay? So every time teacher say R, why is it R? We can repeat, we can write out line 1 you put R, line 2 also put R, because your R is just XYZ. Okay? Yeah, so if I write this is the same as saying these are like X equals to 3 minus lambda, Y equals to 1 plus 0 lambda, Z equals to 4 plus 1 lambda. Okay? R is just XYZ. R is just XYZ. Why? R, it can be a coordinate, it can be a point. When we talk about vectors, okay, if I give you this point in space, okay, 1, 2, 3, okay, am I referring to a vector or a point? A vector, right? If I write it this way, 1, 2, 3, am I referring to a point or a vector? This one is a point. So like that, okay, this one, point. Coordinates, okay? You notice the notation, how they write. Why is it some write in row, some write in what? This one refers to vector. So this one is. Okay, vector means as a direction. Okay, next one. 1D. Passes through Monisha 会议 OK explain 应该拉吧 OK OK OK. Never mind, you ask Benjamin. Okay, I'm sure he's happy to help you. Okay. Okay, passes through. Now we're looking at 1D. Okay, passes through 0, negative 5, perpendicular to both 4, negative 1, 2 plus lambda 1, 0, 3. 4, negative 1, 2 plus mu 8, 3, negative 3. Okay. So now, how do we go about doing this? How do we go about doing this? You have learned this before. What we did is we did a similar question in your lecture question. You realize? There's a similar one on your first page. Perpendicular, right? Here, all I do is I take the vector product of these two. Alright? I have two lines. First one, the first line, right? I can write it in this way. The first line can be written like this. So you notice I use, okay, look at how I write, okay, lambda 103. Okay, this is how you write out the equation. Have to put comma, have to indicate what is lambda. Second line looks like this. You notice I use R for both because R is just XYZ. Okay, but what I write differently is this. I write L1, L2. Yes. R1, R2. Because okay, no, usually R refers to XYZ. R is like that. X1, Y1, X2, X2. I've not seen people use R1, R2. This one I need to check the notation. Which one? No, I can. Just right. Because I'm under can.
Doesn't mean ratio.
No, doesn't mean ratio. Okay, then from here, from here, I take the direction of both. But direction 1, direction 2. I take these two, right? So my line is perpendicular to this. Okay, perpendicular to this, perpendicular to this. What I do? Perpendicular to both of them means I just take the normal vector product. So quickly, 103 vector product with 8, 3, negative 3. Okay, tell me what will you get?
3,
negative 27, 3. Okay, can so you can scalar this down. If not, you can leave it first. Alright. Then after that you go to the question. it passes through 0, -5. Alright, the direction vector is -9, 27, 3. So that is your equation. Then ask yourself, better to take out. Like that you won't be marked wrong, but better to take out. So you ask yourself, is it the best way to represent this answer? If you write like this, okay, you won't be marked wrong. But actually, if you observe -9, -27, 3, what can you do? Take out the 3 lor. So you can write it as. Okay, if you want, you can do this. Okay, also do this. What I can do is I can write this. Also can. What I do is usually I just write this at the start. I don't even write the first line. Because
you used mu before.
Which one? I use mu. Oh, then I use another one.
Because it's like
alpha.
in the question.
Which one? This one, right? Usually, okay, you see, if you can, right, exam, right, you just straight write this. You don't even write the. Don't even try to simplify lah. The best is you don't even write this. You just write this one. Because you can easily take out direction vector. You can simplify. You can factorize out the scalar. Yeah, because if I ask you to indicate me a direction, right? If you write 1, 2, 3, it's the same as it's the same direction as 2, 4, 6. It's the same direction as 3, 6, 9. Okay? So it's the same direction. If you present in a certain way, maybe you didn't factorize now, then you must write this. Okay, safer. Okay, to define your variables. That is for part 1, BMQ1. Tired then eat a sweet. Line is cute. Okay. If it's not perpendicular, does it mean that parallel means not skewed? Means it's skewed. If it's parallel, can it be intersecting?
It can be on the same line.
Okay, you see, parallel, right? First one I can have this. Second one I can have this. Go and die lah. Okay, go. It can be the same line. This is actually, are they intersecting? If I give you one point here, does it fulfill both lines? So this is what we call intersecting at infinitely many points. So these are intersecting. For knowledge lah. But I mean, it doesn't. But doesn't mean parallel means skew. Parallel still can be together. So you can also have 2 lines like that. Why? Like that also okay. Parallel can be like this. Can also be like this. Can be parallel but. Which one? Skew lines means what? What's the definition of skew line? That's one. Okay, so skew lines can be like this, right? Like that also skew. It's not intersecting. Skew lines can also be. Skew lines cannot be perpendicular. You see, one line like this, one line like this. Skew line just means not intersect. Like that, right? Skew just means not touching. Just means not touching. What? Like that, parallel, Skew, still skew, like that, perpendicular, right? Skew, still skew. They're not touching. Okay, so let me go to question 2. Find a vector equation and a Cartesian equation of the line L1. Okay? Understand? Okay, so all you need to do for this, right, you must recognize what is R, what is R. Okay? So here actually, to find the, it's quite easy, it's quite easy. So first one, R, we recognize that R. We can also write R as like our XYZ. We recognize that R can also be XYZ. Okay? For DMQ 2A, our R looks like this. It's actually 2 plus lambda, 1 minus lambda, negative 3 plus 2 lambda. You can see that I purposely put the constants to one side, put those with lambda to the other side. Stop. Okay. Okay, then after that, what can I do? I just split. I split. So it's not difficult, you just split. Okay, quickly you have 2, 1, negative 3 plus lambda, 1, negative 1, 2. Okay? And lambda is what happened? Falling asleep. Go and do push up. Do the push up. Okay. Really, it's very good. Very good. Tested and proven. 30 years of experience. When I was in the army, I never got caught for falling asleep. No, I never fall asleep. Because every time I fall asleep, I do push up. Okay. Huh? Okay. Finish anyway? Okay. Okay, so this is the, what kind of equation is this? Vector or Cartesian?
Vector.
Why is it vector? Why not Cartesian? Cartesian is XYZ, vector is like this vector form. Yeah. Okay, after that, that's the vector equation, How to find the Cartesian? Very good. I recognize that actually this is 2 plus lambda, 1 minus lambda, negative 3 plus 2 lambda, right? Correct. This is my original equation. R I just replace. I put as XYZ. What next? I make. Yes, I just shift. I just do rotation. Okay. Make lambda the subject. Okay. X equals to 2 plus lambda. Lambda equals x minus 2. Y equals to 1 minus lambda. Lambda equals to 1 minus y. Z equals to negative 3 plus 2 lambda. Lambda equals to z plus 3 over 2. Very quickly, you can get all the answers. Okay? 1, 2, 3. And you know that lambda is equals to all three of them. So lambda is just equals to x minus 2 equals to 1 minus y equals to z plus 3 over 2. Yes. Generally because that's the template. The template, you know, every time when the one you see on notes, x minus a over something equals to y minus b over h over k equals to so, but it doesn't matter. It will be marked wrong. Okay, so z plus 3. So this is your, with that you erase the lambda. This is your Cartesian equation in terms of x, y, z. Okay? Can. Okay, is anyone able to do part 2b? Kabi can do? Can do. Okay, come, Kabi. Come pass me, I take a picture. Okay? Why? Okay, so from here, did everyone get this answer? Good, okay, okay, but the generally, okay, everything is good. The answer is perfectly there. Only small thing to change is maybe we take away this negative sign, this equal sign. So this is the answer. Okay, this whole thing will be the answer. Okay, this is the Cartesian equation. Vector equation is below. Right, both are okay. Why? What's wrong? They ask for vector equation. Oh, sorry. Okay. Then it's vector equation. Cartesian equation is here. Okay. But when you write equation, common presentation mistake. People do this. They find the Cartesian equation. They go and write lambda equals to x minus 1 over 2 equals to y plus 1 over negative 3. Then after that, z equals to negative 1. Some people go and do this. Put equal. No need. Don't that wrong already. That mistake. Okay. We must put comma. Some people leave the lambda equals there. No need. Okay. You just take away. Okay. This is the answer. Don't go and put lambda equal. Don't go and put. Okay. 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 Next. Okay. For each of the following pairs, we want to find the position vector of the points. So for number 3A, anyone manage to do 3A? Okay, very good. Someone ask me the. Can I ask? Anyone can do? Either can do? Okay, come. Let me take a photo. Okay, so let's take a look at this. Okay, for 3A, right? We need to see if the lines are skewed. Okay, find the position vector of the point of intersection, if any. Okay, so first one. Oh my god. Okay, this is the first equation. This is the second equation. This is the second line. Okay. Alright, so so now you see why I spent so long to mark the words. Okay. Okay, so from here, right? This is the vector equation. Okay, what you how did I define the vector equation of line 2? Okay? Yeah, are you with me? Stay with me, okay. Stay with me. Vector equation of line 2. Okay? After that, here, right? What you need to add here is this. Okay. Listen. There's some presentation. Small. Here, right? Try to add this. Okay. If the two lines intersect, that means you say that there exists mu and lambda such that this is true. Such that this is true. Okay. Try to simplify. You can put ST可以写which is 2 plus 5 equals to 5. 2 mu plus 5. 2 lambda. This is lambda, right? Oh my. Mu is on the right hand side.
I use mu because my left on top the L1 I use lambda.
Is it correct? Yeah, what am I writing correct? Oh, I want to cry already. Because your right hand side, your left hand side is mu. Then right hand side also mu.
Yeah, because this is the equation. Sorry, I split the.
Oh, okay. Oh my god. Oh.
Cancellation is supposed to be.
Okay. Correct. Okay. Can. So this is correct, Then with that, right? What I'm doing is this. If the two lines intersect, there exists. Then we should add it here. There exists mu and lambda such that you have the first equation, the second equation, and the third equation. Alright? So these two are three equations that we need to solve. Okay, you need to solve all three. You take any two equations to solve. If I ask you to find two unknowns, how many equations must you have? 6. Who said 6? I give simultaneous one, right? I give x, y, find x, y. Usually how many equations? 2, right? If I give 3 equations, you need 3. You all do the equation, system equation, correct. Correct. 6 values. Oh, okay, that's what I mean. Okay. So from 2, right, you can solve mu equals to -1, correct? Okay, then from here, you have lambda equals -1. What mu equals to 1, lambda equals -1. You find the answer. Okay. the two lines intersect at 7, 4, negative 1. Okay? Yeah, and are not skew lines. So these are perfectly well done, okay, by Chua Yu Hao. Okay? Okay. Okay, I'm good. Okay, next one is 3B. 3B. Okay, so 3. Okay, here, right, R is equal to 2, 3, negative 1 plus 2, 3, negative 1, 4, 1, negative 1, 2, 1, negative 1. Okay, so from here, we need to determine if the lines are skewed or is there any point intersection. How do we go about doing it? First one, let's write it this way. L1, this is R, equals to 2, 3, negative 1 plus lambda 2, 3, negative 1. L2, again, Ricardo, you ask? Huh? Okay. 4, 1, negative 1 plus a mu. Now I use mu, 2, 1, negative 2. Okay? Do we assume that they intersect?
Yes.
Okay. So if you want to check the relationship of two lines, they could be parallel, could be intersecting, right? How do you check parallel?
They're the same direction.
The same direction vector or the
Lambda.
they can be scalar multiples, but most importantly, parallel and intersecting. Is it easier to check parallel first or intersecting first?
Parallel.
They also always, our lecturer tell you check parallel first, then you check intersecting. Okay, so now you can see not parallel, not parallel. Okay, so next one you do check intersecting. Okay, so just let that exist. If they intersect, if L1 and L2 intersect, means there exists mu lambda such that 2 plus 2 lambda equals to 4 plus 2 mu. 3 plus 3 lambda equals to 1 plus mu. Negative 1 minus lambda equals to minus 1 minus 2 mu. Okay? Yeah. And let me ask you, okay, so now we're going to solve that. Okay? You are going to, all your answers may be different from mine. I need to tell you first, okay? Because, okay, if you use 1 and 2, if you use equation 1 and 2 to solve first, you will get this lambda equals to half, mu equals to 7 over 2. Okay? Anyone got a different answer? Benjamin, what do you get? Which equation do you use? Huh? Keyhole left, what answer do you get? Which equation do you use?
I simplified 2, then I substitute
3. 2 again. Which equation do you use? Do you remember? Okay. Okay, very good. So why is it we all get different answer? Because the lines actually they don't intersect. Okay, so I show you why I show you. Okay, very simple. This is how you check. If you forget what I say or you are tired now, go back home, watch the video. Okay, and try to absorb as much as you can. I use equation 1 and 2. I get this answer. When I sub into 3, answer don't satisfy. Okay, you can see that left hand side if I put negative 1 minus half, right hand side I put negative 1 minus 2, 7 over 2, they are not equal. Okay? Wow. That I don't know why. Let me check. You should get the same answer. Okay, you could be your lambda and mu is different from mine. Could be lambda and mu is different from mine. There are a lot of differences. And so here you sub into 3 cannot. Some of you use 1 and 3. Then you sub into 2. Also cannot. Okay? The objective is this. You forget everything I say, just remember. You take any two equations, you find the answers. You must sub into the third one. Don't happy say, first find 2, got lambda, got mu, therefore happy already. You must sub into the third one. Check that it satisfies all 3. Check it satisfies all 3, Okay, Check it satisfies all 3. Okay? Alright, okay. So the idea objective is it does not satisfy. Okay? Next one, 3C. How about 3C? Can anyone tell me the answer for 3C?
They are parallel.
Okay, very good. They are parallel. They have a different. Okay. So next one. Okay, let me ask you: are there any point of intersection?
No.
No, right? No, right? So very easy because two lines are parallel, right? But if they have different position vector, right? Can they still be intersecting? Huh? No. So all you need to do is because okay, they are parallel. You just need to write L1, L2 are parallel lines. And not intersecting. Okay? They're not intersecting. Then they are and the same. Correct. Yes. 3C. One, oh sorry, one minus one. Oh, no one even recognize. Minus one, minus one, one, minus one. Okay. Okay so far? Can joke a bit but must stay awake stay awake. Okay. Hey, don't to stop flirting. This kind of thing only boyfriend and girlfriend do. Migalaba and Benjamin are talking in my class. This one I show to the math teacher only. Yeah, it's recorded. Okay, Okay, next one, PQ question 1. Okay. Don't argue. Joking. Okay. 2 negative 1 4. And 1 negative 2 7. Find a vector equation of the line passing through P and Q. Okay? So some very easy. Okay, very quickly. Okay, I know you're going to get the two equations. L1. Okay, I know you all can get this, right? 2 negative 1 4 plus S 1 1 negative 3. Okay? Okay, I'm quite happy that a lot of you can now do more of the tutorial each time. So it is very yeah. It means you all really put in the effort, go and watch the video then try. To me it's the effort that matters. Okay? Okay? Given that they intersect, this is the part where Praveen has asked. Okay? Given that Praveen and Monisha intersect. Then there exists. You know why? Because she was talking while I was presenting, so I need to catch her attention. That she was talking non-stop, so I need to flag. Okay, so such that 2 plus S equals to negative 1 plus S 4 minus 3S. So you see now we don't use any, we just use S and lambda. We choose any variable that we like. Negative 2 plus lambda A, 2 plus lambda B. So actually from here it's not that challenging. So you just try. Just try from here. Anything you observe not? Monisha, anything that you observe? Can you find the value of S?
Yes.
Observe the equation. Which one? Last one. This one from here you can get S. S to be equals to 2 over 3. Okay? And all you do is just happily sub into the first equation. First equation, the first two equations you just sub. So from here, you have 2 plus 2 over 3 equals to negative 2 plus lambda A. You can get lambda A to be 14 over 3. This is from the first line. Over here, if I sub this, negative 1 plus 2 over 3 equals to 2 plus lambda B. You can get lambda B to be negative 7 over 3. So here, what can you show? Very good. Very good. Lambda A 14 over 3. Lambda B negative 7 over 3. Can see already? Just take divide by each other. Divide. Okay? You get A over B equals to 14 over negative 7. A equals to negative 2B. So, okay?